Hey guys, welcome back to CMTEQ channel. So this is a follow-up tutorial of our simple analog to digital converter, where we basically design a simple analog to digital converter using an RC filter and the op-amp voltage buffer. So in this tutorial, we basically adding up the display functionality to show our analog data here to display on a 7-segment display in a form of a counter. All right, and this tutorial will be divided in two parts. So the first part will be discussing the 7-segment display, and the second part will be the LCD display, where we can actually display the decimal values as well, because on the 7-segment display we will only display simple digit. Right now, before we explain what's going on here between the Arduino and the 7-segment display, as you can see, we've got shift registers and a couple of resistors. So let's first briefly explain the functionality of a 7-segment display and the combination with a shift register before we couple it with an Arduino. So stay tuned, let's get started. A 7-segment display is basically a strings of LED connected in a way that when lighting up each one of these segments here, you can basically configure and display a digit. Right now, all these segments, they basically represent LEDs, so which means if you connect a 5V and a resistor, you can choose to light up which section of the LEDs and create your number. This basically means you can configure a 7-segment display and lighting it up manually using switches, right? But now we've passed that stage. We're now using microcontroller to configure the 7-segment display. Okay, so now using a microcontroller, so all you do is you use digital IOs to basically decide which pins you want to turn high and low to get your decimal value display. So now if I want to display number 3 here, now let's say all these segments, they basically represent a binary number, okay, binary number string. So if I want to display number 8, basically all these binary numbers, they must be turned as 1. So I must write a 1 here to display number 8. So if I want to display number 3, I must turn off F and I must turn off E to display a number 3. So which means if I'm writing a program, I need to write E here, 0, right? And I need to write F also, 0. That way, I'm going to display digit 3. So by doing this, you can display any value you want to. Now you can decide to do this manually, or you can use a microcontroller to do this via a program. But now there arises another problem, because all these bits here, they basically represent an IO on your Arduino. Now, if you are using a microcontroller with limited number of pins, you have a problem, right? Especially if you have two of this digit here, you want to display 2 decimal value. So you're going to run out of pin out, because you'll need double the number of pins. And this is where the shift register come into play, right? Because with the shift register, you can basically just use 3 IOs and connect it to the display, and it will cleverly drive your 7-segment display. So now let's go ahead and see how a shift register can use to basically light up the 7-segment in a way that you want to get the digit that you want. A shift register is basically a serial in. Then I need to move to the second bit here, 0, high, low, another 0, high, low. Then I need to enter this 1, high, low, another 1, high, low, third one, high, low, and the fourth one here, high, low. Now I've entered all these bits here. So the next thing I need to do is now to trigger the storage register bit, so that all the data that have been entered can now be displayed on the output port. So let's go. You can see there, number 3 have been displayed. But now this is manually, right? Because the shift register will not understand which one is the MSB and which one is the LSB. So that way we're going to use the Arduino code, and the Arduino code we're going to use a shift out function that will already know which one will be the most significant bit and which one will be the least significant bit. That way the shift register is going to deal with it in a synchronized manner, and we're going to have our number display on the screen. So let's go ahead and do that. Now let's take a look at what's going on in this schematic diagram. So we've got 2 shift registers connected in cascade mode here. If we're seeing the type here, so let's select the type So that is going into the Arduino Uno. Okay, that's all we need, and we can export compile binary. Okay, so I'm going to post this code on GitHub for anyone who want to access this code. It's going to be on the GitHub. I will post a link on the description of this tutorial. Then once the compilation is completed, let's now go ahead and load it onto our Arduino. Here we need to navigate where it is connected. So it is this file, right? So that's a PWM DAC Uno, so we then need to load it in. Great. Now let's go ahead and give this a run. Okay, so the display is displaying 0. Okay, we already got 1 here. You see, as soon as we go to 1, we've got also a 1. We've got a 2 here, then we're also displaying a 2, and our PWM duty cycle is increasing as well. Okay, so we got a 4 is also being displayed. So that is basically how you can display your analog data, right, from your conversion onto an LCD, onto a 7-segment display. Now, as you can see that we are not displaying the decimal part, so this will only be possible if we connect an LCD display. So that is why please tune in onto the next tutorial, where we're going to basically set up an LCD display to display the analog data coming from our converter here. So thank you guys for watching. If you found this tutorial useful, as always, please give it a thumbs up and subscribe to CMTEQ channel. That would be highly appreciated. Until next time, cheers.